let's get started. Let's get started. Okay, so you got your PS3 that's out and due Thursday. Another announcement I have is that we've changed the way we're handling the one-on-one consultations with TAs. We sort of experimented with it, and all the appointments were with Stefan in his office. But from here on out, I'm going to have rooms reserved over in MEB near the CADE lab. And there'll be multiple TAs that are servicing the appointments. So I don't quite have the schedule up yet. I do have a schedule for tomorrow, though, that you can make reservations or make appointments. So I'll make an announcement when that's ready to go on a full-time basis. So are there any questions or problems before we start? Okay. I thought I'd start by talking about PS2, because you've all thought about it. And I decided for no real good reason to look at this is earlier than method. And I know that I saw a lot of solutions, and I saw a lot of people doing it a different way. But there's a lesson to be learned in here about string comparisons if we do it a certain way, so I want to look at that. So what I've got in JShell here is I'm just comparing two dates, year, month, day. And just comparing them as strings. And the compare to method will tell you whether the first string comes earlier in the alphabet, at the same place in the alphabet, or later in the alphabet. So it's not, you might say that what that thing does is it tells you whether the first string comes before, at the same place, or after in alphabetical order. But why is alphabetical order the wrong word here? What's wrong with saying alphabetical order in this case? Yeah?
If one has a capital and one has lowercase.
He said, okay, so he talked about capital and lowercase. So it turns out capital A and little a don't come at the same point in the alphabet of Java. But what's more pertinent, there aren't any letters in this. Yeah?
It's more important to think about it like the ASCII number behind the 12 characters in there. So like the 2 is an ASCII number.
Okay, so he's talking about ASCII numbers. But what I'm getting at is what matters for this comparison is what happens when you compare. I mean, the strings are the same up until you're comparing the 2 in February to the 1 in January. So the question becomes, how do 2 and 1 compare in alphabetical order? Well, they don't. Alphabetical order doesn't talk about digits. So we need something more general than the alphabet. And so what Java uses is called Lexicographic Order. But what that boils down to is every character up there is represented by an integer internally. And so when Java compares characters, it's just comparing integers. So for example, let's compare A, middle A to capital A. It's just going to compare the internal code for A to the internal code for capital A. All right, and that'll either be true or false. It turns out to be false. All the capital letters, their codes come before all the lowercase letters. That's just lexicographic order. You might ask what happens when you compare A to the character 2, which comes first. I mean, there's no way a priori to know this. Okay? Turns out the digit 2 comes before the character A in the lexicographic order. So the integer codes that are used as stands for letters are called Unicode. So Unicode is 16-bit standard, so every character from lots of alphabets, math symbols, and so on all have a unique number, and that's what happens when you compare. But here we just got to compare digits, and it's enough to know that 0 comes before 1. The character 0 comes before the character 1, and the character 1 comes before the character 2, and so on. So how can we use this observation to implement is earlier than? We want to know whether some date is earlier than some other date. What's the trick? Yeah?
Use compare at and then say if it's less than or equal to or greater than 0, then do different things.
Okay, so what we want to use is compare to. So as long as the strings are written, as long as the dates are written in this form with a 4-digit year, followed by a 2-digit month, followed by a 2-digit day, then it turns out that the way Java compares strings will work just fine to compare dates. So you can see that this one here says that that date comes later, which is right. Now if I change it a little bit, okay, what's it going to say now? I've made it so that we've got January 1st, or January 9th compared to January 19th. So we get -1 back, which means the first string comes before the other string in lexicographic order. And if I change it further, we found out they're the same. So that's a nice observation, but what's the problem? Yeah?
If the year comes after the month.
Right, the problem is the inputs we're getting to the method aren't written in this form. It's written in the form month-day-year. And then our trick doesn't work, because any date in January will look like it comes earlier than any date in February. We need to have the year come first, then the month, then the day. So this is a very common situation in programming. There's a problem we want to solve, and there's a way to solve it, but they don't quite match up. So what do you do when you have that situation? You've got a solution that almost works, but doesn't quite match up with the input you're getting. Yeah?
Just rearrange.
Right. Rearrange the input. Transform the input so it is what you're looking for. Okay, I can't stand this feedback anymore. So. Okay. Can you even hear me now? Is this okay? How's this? Hopefully it doesn't have the reverb. Okay, so the idea is we're going to come up here and we're going to transform date 1 into a new string D1, which is has year, is in the form year, month, day, and similarly for date 2. And then all we have to do is this. We'll return D1 dot compared to D2. That's what we'll.
That's not quite the variable.
Okay.
The variable.
So what we need to do is define D1 and D2. Right? It'd be nice if we could return date 1 dot compared to date 2, but they're not in the right form. So we need to modify them to be in the right form. Now, before I show you how we can redefine D1, how we can define D1 and D2, I want to try to cure you. I've tried with this assignment to cure you of something, for some reason, that people just love to do. And this is what they love to do, is that if they need to return a Boolean, they'll say, if D1 compared to D2, return true.
Doesn't return true.
Yeah, it's not a Boolean statement.
Yeah, that's what we need to do. Well, it'll return -1 if D1 is earlier than D2. I actually point that out. So if D1 dot compared to D2 is less than 0, if D1 comes before D2, we return true, else return false. And I can speculate about why folks want to do this. But of course, the simplest thing, if you ever see, if some Boolean condition is true, return true, else return false. Why the heck don't you just say, return the Boolean expression, return the value of the Boolean expression? That's, you know. If that expression is true, we want to return true. If it's false, we want to return false. So just return it. Return its value. Okay? So that's why I said no conditionals in this assignment, because I wanted to try to break you that habit. Okay, so we need to define D1, and we need to define D2, and then do the comparison. So how do we rearrange date 1 so that it's in the format we want? What do we have to do? So it's going to be, let me give you an example here. We're going to have 01/09/2018, and we want to turn it into that other form. Yeah.
Use the subscript or whatever, substring.
Right, we can use the substring method to take this thing apart. So how would we pull out the date? Let's see, it's 0, 1, 2, 3, 4, 5, 6. That 2 is at index 6. And we need to give it a non-inclusive other bound, so 6, 7, 8, 9, 10. Or, yep, even easier, if you just say where to start and just go to the end of the string. So that pulls out the year. Okay? Then we need to pull out the date, the month and day combination. Okay? So what would that look like? What's the index at which we start? 0. And the index at which we need the index 1 beyond where we want to end. So we got 0, 1, 2, 3, 4, 5. So that ought to give us that. So now that I've got my experimentation out of the way, I can come up here, and date 1 is going to be, D1 is going to be date 1, we can pull the year out. We need to put the hyphen in. And then we need to put the month and day in. Okay, so that just does what we experiment with in JShell. This will be the year, then a hyphen, then the month and the day. So it's just rearranging where you want it. We can define string 2, D2 pretty much the same way. Okay. And then if we want to see if we got it right, we can run the test case. And actually we passed that and failed all the others. So that's what we expected. Okay? Now, imagine a lot of you did it a different way, and that's fine. I'm just trying to make a bigger point here that this is a common thing. You've got library methods that don't do quite what you need to do, so you just have to do a little bit of programming to connect what you have to what you need. Okay. Any questions about what I just did? Okay, now, I get lots of questions from folks lately. They say, my method is... Okay, go ahead.
And how... Never mind.
Okay.
Actually, I don't know. One sec.
Well, you think about it for a bit and let me go on here. They'll say, I believe my method is correct, but it's failing the test case. You know, what do I do? So I want to point something out. Let me just, suppose we made that mistake. So we're given the wrong answer. So let me rerun the test cases. So I'm going to come here to rerun them. And it failed is earlier than. Okay? So how can you find out why it failed? You don't just have to, this isn't a black box. It's like, I get the feeling that a lot of you are thinking, okay, I failed the test. I got to figure out why. JUnit will tell you why. Who knows how to find out why? Yeah? Say again? You have to say, talk really loud.
Oh, doesn't it say at the bottom left?
Yeah, so if you click on the test case here, first of all, I double clicked on it, and over here it showed me the assertion that failed. So we know we failed that assertion. And usually down here it will show you what it was, why it failed it, what it was expecting, and what it actually saw. But I think the problem here is that we can tell it wasn't true, it was false. Okay? So you can tell what assertion it failed. And often there's more information down in that lower pane that will show you what the method returned and what it was expecting to see. Now, suppose we made a different mistake. Let's say we got that right, but suppose we did this. Okay, so we're going to get an exception because we're looking beyond the end of the string. So now if I rerun the test cases, then I get down here what's called a stack trace. And that's way too small for you to read, unless you're in the very front row, maybe not even then. The way to read a stack trace is from the bottom up. So it says that, it shows you we were running on line 105 of testcases.java. So I double click, it says that assertion was invoked. What the assertion did was call is earlier than. So you come up on the stack trace, it'll show you, okay, then we went to line 135 of is earlier than. And this next one, if we click on it, we're into the library. So no need to go that far. You can come back to here. So you want to get into the last piece of your code before it went into the library code. So the problem occurred in here. So it'll tell you what line the problem is on. It tells you up here that we called string index out of bounds exception, and the ending index was 12, but the link's only 10. It's telling you exactly what's wrong. So you can figure out where it went wrong, and you can figure out why it went wrong. And if that's too confusing, you can even set a breakpoint there. And then you can run, when you run the test up here, I can just right-click on this thing and say debug this test case. And it'll run it in debug mode. And we'll hit the breakpoint inside the test case. And then we can go from there, and we can step into our method like you saw in the lab last time. So we step in. So I thought I stepped in, now I stepped out. I'll try again. No, I'm not gonna. Sometimes you end up a place you don't expect when you step in. Oh well. Sometimes it works right. So you can use the full, use your debugger to debug what's going on in the test cases. Okay, so I just wanted to point all that out. Are there any other methods of particular interest from PS2?
Yeah, several. Let's see. Oh yeah. How about a largest of 5?
Okay, largest of 5. So I got an email from a TA this morning that was grading PS2, and she had found a solution. I guess it was a correct solution that was really so bizarre isn't quite the right word, but it found the max of 5 by the operations it did were addition, subtraction, division by 2, and absolute value. And she asked me what I thought of that, and I hadn't replied yet, but I think what it comes from is probably Googling a way to do max without realizing that the Java library has a max method. Okay, and you end up with a really complicated way to do it when there's actually a really simple way to do it. Okay, so what is the way to do it? Given that there's a max method in the Java library. So we got a max method on one end, and we got a string that contains integers on the other end. So there's a disconnect, right? How can we bridge the gap between the two? Yeah?
Convert the string integers to regular integers, and then use the max.
Okay, so somehow I've got to extract the integers from that. How do I do that?
Scan.
Right, so I need to use a scanner. So I'm going to say, okay, so we'll create a scanner to read from the integer list. Okay, now I've got to get the integers out. So one thing I could do is do scan. I could do s.nextInt, s.nextInt, s.nextInt to get the 5 out. But let's try doing it this way. Let's take the larger of the first 2. So what will that give me? What's going to be an M? In fact, I'll just call it max for the heck of it. What's going to happen when I do that? What will max contain? Yeah? Right, the max of the first two integers on the list. Now, why am I not calling has next int? Why am I not testing the scanner to see if there is a next int to be read? Yeah? Yeah, it tells us we can trust that they're 5. It doesn't matter what the method does if there aren't 5, so we just assume they're 5. So I read the first two, take the max out. Okay? Next, what will be the next step then? Yeah?
Take the max of max and scan next.
Right. I take the max of the largest I've found so far and the next int. And then I do it again. And then I do it again. So at that point I've read 5 integers. I've called next int 5 times, so I've got all the integers. And so actually that last one I don't need to put in the max, I can just return it as the answer. So there's one way to do it. There are lots of ways to do it. I don't mean to say that some ways are better or worse. They're just different. Yeah?
So like no matter where you put it or where you like put next int, Java will know that for every one is like the next digit, I guess, in the integer list.
Yeah, so to understand what's going on in here, you've got to, first of all, understand the order in which statements are evaluated. So we have 5 statements here. In what order are they evaluated? Which one is done first? Which one's done last? Yeah, back there. Okay, he said the scanner's created first, and then it just goes one after the other until it hits the return statement. So when it hits this statement right here, it has to call max. What does Java do to prepare to call max? Go ahead.
Gets the first 2 integers out of the string.
Right. When we're calling another method, what Java does is okay, this is the first parameter. It doesn't pass s.nextInt to the method. It evaluates that expression. Every expression has a value, right? So it evaluates the expression, and the value of that expression will be whatever the first int is. And then it evaluates that expression. Or actually, I'm not sure what it does. It may do this expression first and then do that one. It doesn't really matter in this case. But in any case, it will read let's assume it does it left to right. It will get the first integer out of the scanner, the second integer out of the scanner. Once it has those values, it calls the method. So values are passed to methods, not expressions. Expressions are evaluated, then the method is called. Yeah?
Technically, it would be problematic if it did right to left, because then you'd have the first number on, or actually no, it's actually.
It'd be a problem if we were dividing instead of taking the max. Then the order would matter. And I just can't remember. Some languages don't specify an order, so you have to be careful. Other languages do. Okay? So the net effect is, after this statement's been executed, there have been 2 integers pulled out of the scanner. The next line evaluates max, looks up max in a table, evaluates that expression, which is going to be an integer from the scanner, calls the method, stores the result in max. And on it goes. So by the end, we've gotten all 5 out of the scanner.
Can you talk about the scanner warning?
Okay, we've gotten a lot of this lately too. People look at the scanner and they see, it's underlined in yellow. That's a warning, and it says resource leak, or S is never closed.
Oh, yeah.
Okay? Now, what you gotta, if you want to get rid of that, you have to close the scanner before you return. But I can't do that here, can I? Because I'm using the scanner in the return statement. So here's the answer. Yes, when you open a scanner, you should close it. But for the time being, don't worry about it. It's just fine. It's not a problem. I'll show you the right way to do it in a couple of weeks. But There's a nice way to do it, and but I don't feel like explaining it now. Okay, now we've been talking about loops. How can we change this method so that it didn't assume there's 5 integers? How can we make it work as long as there's at least 1 integer? How could we change it? So I'm going to comment this out. First of all, I'll comment it out. Okay, how can we rewrite this so that it'll work no matter how many integers are in the scanner? Yeah?
If you put it a while loop and have it as next.
Okay. So what she's suggesting, first of all, we need to create the scanner. So we'll do that. And then she's suggesting while there is a next int. Okay, so that's sort of how you consume a scanner, right? While there's next int, you need to do something with the next int. Well, what is it we need to do with each int as it comes in? Would this work? Can we do this statement over and over again? And then when we're all done, I need to declare max. It needs to have an initial value. But you get the idea here? Would it work to just, until there's nothing more in the scanner, set max to be the maximum of the old value of max and the next integer in the scanner? Seems like that ought to work. But we've got to give an initial value to max. Yeah?
0.
Well, she said 0. That would work if we knew all the integers were positive. But if all the numbers are negative, we don't want to return 0 as the answer. I had a hand up over there. Yeah. Okay, so what he's suggesting is okay, if we're willing to assume there's at least 1 integer in the scanner, which is what I said, then what we'll do is we'll pull out the first integer and let that be the max, the largest we've seen so far. Each time through, we will update max to be the, so think of max, in fact, let me refactor this. Remember, I can refactor, rename. I'm going to change this to largest so far, just to remind you. So initially, the largest we've seen so far is the first number in the scanner. Each time through the loop, we update largest so far by taking the max of largest so far and the next integer in the scanner. When we're all done, the max will be in largest so far. Yeah?
What if there's only 1 number in the scanner?
Okay, what if there's, she asked, what if there's only 1 number in the scanner?
The while loop will fail, and then just go straight to the return.
What did you say?
The while loop will fail, and then it'll go straight to the return.
Right, if there's only 1 in the scanner, this statement will work. The first number from the scanner will be stored in the variable. This will return false, because we just read the only integer out, and we'll return that integer that we got, so it worked perfectly. The only time it will blow up is when there are no integers in the scanner, and we'll get an exception, a no such element exception, when we try to read that non-existent integer. But I told you could assume there was at least 1. Now, will this pass the test, do you think? Will this pass the unit tests for largest of 5?
Well, didn't,
Let me run it first here. So let's go to JUnit, and I'll oh, that's weird. It's like it went into a loop. No, let me just run the test cases this way. Okay, it's just testing the 1.
I think installed the breakpoint.
Well, I'm running. Okay, there we go. Yeah, test largest of 5, it passed. So that's not surprising. since it ought to be able to work if there are only 5 elements. Okay, any other questions? Yep.
What do you do, for example, in add numerals? If you can you just have the scanner take two get two strings in one go? If you just do like integer 1, comma integer 2.
Well, there's no need for a scanner down here. What you do is you turn these strings into big integer objects and add them.
Oh.
The solution for PS2 is available on Canvas. You can pull it up from the Canvas project manager.
Oh.
So I encourage you to do that. Take a look.
And also, when you're making a scanner, when you put your string or other variable in there, and when you just put system.in.
Okay, so she's asking about the scanner constructor. Here, there are several versions of the scanner constructor. This one, we passed in a string. There is also a version that will take in system.in. And she asked, when do you create the scanner from a string? When do you create it from system.in, meaning the keyboard? You can pass in a file, and it will read from the file. How do you know which to use?
Oh, system.in refers when you're typing something in.
What decides the source that you're getting your scanner data from? The thing you're scanning. Yeah?
Context of the problem?
Yeah, the context of the problem. If you're supposed to read your integers out of a string, you create the scanner from the string. If you're supposed to read it from the keyboard, you create the scanner from system.in. Okay. Now, last time we looked at searching loops. So we've looked at accumulation loops, which sort of combine all the elements of a collection together, like adding together a bunch of numbers. We looked at searching loops, which are looking through a collection of things for the best thing in some sense. And the third kind of loop that we're going to look at today are called optimization loops. An optimization loop is you got a collection of things and you're looking for the best. I said the wrong thing about searching loops. Searching loops are just looking for an element that satisfies some property. Optimization loops, we are looking for the best. Now, have you ever seen an optimization loop? Yeah.
You just barely made one there.
I just barely wrote one, yep. There you go. There's an optimization loop. Because we had to find the largest integer in that string. So that's an optimization loop. So you'll notice an optimization loop when you've got to find the largest, or the heaviest, or the prettiest, or the weirdest, or whatever. There'll be some EST thing involved, or most, or something. Okay? So in this case, we wanted not the longest, but the largest. So this is an optimization loop. Now this is an optimization loop that consumes a scanner. If I took out this, and this, and this, you basically got an enumeration loop left. So to turn an enumeration loop into an optimization loop, you need a variable that contains the best so far, largest so far, longest so far, shortest so far, whatever. You initialize it somehow, and that depends on how the problem is stated. Then when you're done, you return its value. And what happens inside the loop? So we declare the variable, we return its value at the end. What do you have to do each time through the loop? Yeah, go ahead.
Compare it to the next value or
Right.
that's going to be passed.
In this case, since it's a scanner, you take the next value out of the scanner and you compare it to the best you found so far. And if you've got a new champion, you set the largest so far or best so far to it. So by the time the loop ends, you will have every number would have had a turn, every element would have had a turn. and the best that was found overall will be in largest so far, and you return it. So that's an optimization loop. So let me show you the, okay, this is the slide for optimization loop. So we're trying to find the largest, the smartest, the nicest, whatever, some superlative. And a common problem comes, what if there aren't any elements? What if you're asked to find the best in an empty set? You know, who has the highest GPA from this set of students and the set is empty? What are you supposed to return as an answer to indicate that there, you know, there's got to be some way of indicating that there were no, that there was nothing to choose from.
Throw an exception?
One thing you can do is throw an exception, but next week we'll look at exceptions. This week we won't. Okay, so this is an example of an optimization loop that consumes sequences of integers. So at its basis, you've got, you know, you initialize the counter variable right there, int I equals, you initialize the counter variable. While I is less than start plus n, you do something. So let's look at what we're doing. First thing we're doing is we create this variable best so far, and we initialize it to hold I. Now why do you suppose I chose I?
Wait. Isn't I not declared yet?
No, that's a good question.
Maybe it would start.
Yep, I made a mistake here. We'll just keep it here so I can fix my mistakes. Okay, I'm going to initialize best so far to start. So why did I initialize best so far to start?
It's the first thing.
What's that?
It's the first thing that you look at.
Right. So up here it says, I'm assuming there's at least one element. So I just take the first element and make that best so far by default. That's sort of what I did with max, right? Well, that's not what I did with max. Never. Yeah, it is. Yeah, I took the first element from the scanner and that was my max so far. Okay, then I have a regular old enumeration loop, except that instead of starting I at start, we started at start plus 1, because we already took care of the first integer. Inside the loop, we just have an if that says if I, our current value, is better than best so far, whatever better than means, then best so far's new value is I. Then when we're all done, we just return it. So that's an optimization loop. On integer intervals when there is at least one element. But what do you do if there is no, what if there's no guarantee that there is one element? What if n could be 0? Yeah?
Throw in an if saying that if n is 0, then...
Well, if n is 0, we still got to return something.
Right, so put a return inside the if.
Yeah, but the question is, what do we return? What's that? Well, this here, yes, this, if n is 0, this would return start. But if n is 0, start doesn't really matter because there are no elements to choose from. So, if that's the case, you just have to agree that there's some, what you do is you initialize, instead of using the first value in the interval to initialize best so far, if this interval can be empty, we're going to initialize best so far to some impossibly bad int, that any other int we're going to encounter is better than. So one thing I might do is make best so far be the smallest, most negative possible int, integer.minint. And then I just run the loop as before, except I start at start instead of start plus 1. And then when I'm done, if I return this impossibly bad int, that's the sign that that there weren't any elements to choose from. Otherwise, I return an actual answer. So there's always that possibility that the interval is empty. Okay? Here is a string optimization loop. And again, it looks like the enumeration loop, except we initialize best so far to be the first character in the string. We start the index generation at 1 instead of 0. And each time through, we see if the character is better than best so far, and if it is, we set best so far to that character. If you can't assume there's at least one character in the string, then we set best so far to some impossibly bad character, and go as before. And what impossibly bad means hinges on what best means, so I can't exactly say what it is. And then we solve a pattern for scanners. Okay, so we initialize best so far to the first thing in the scanner, and then we read elements in the scanner. Here's where we read. And if the token we just read is better than best so far, we update the token, and then we return. Yeah?
So inside the while, what is it basically saying? Just saying scanner gets or has next or something?
This here?
Yeah.
Okay, so SCN is our scanner, so we're just asking the scanner, is there a token? If I ask for a token, are you going to give me one, or are you going to throw an exception? And when the scanner becomes empty, has next will return false, and the loop will end. But as long as it's returning true, we are entering the loop, safely reading the next token, because we know it exists, doing something with it, and then seeing if there's more. So that consumes the tokens. Okay. Any other questions I could answer? Okay. Well, let's take a short break and we'll write some optimization loops. Okay, let's get started again. All right, so we're going to write some optimization loops. So here we have a method. You're given an integer. Let's say it's 10. You're supposed to find the integer between 1 and 10 that has the largest cosine. Okay, and we'll assume that n is not going to be 0. There's at least one number to test. Okay, so an optimization loop. So I told you an optimization loop is based on an enumeration loop. You just got to add a few pieces. So I'm going to go to the enumeration loop. We'll find an example of a, here's an enumeration loop on integer intervals. I'll copy it. We'll paste it here. And now we've just got to customize it for what we're doing.
Where'd this come from?
I just copied, it's just from one of last week's lectures, enumeration rule. Okay, so there's no start here. Start is 1, right? So, just implicitly 1. So I'm going to set this to So what do we have to do to turn this into a enumeration loop? I'm sorry, an optimization loop. So we're starting out none at 1, and while none is less than or equal to n, we do something with none. That's what the enumeration loop says to do. We've got to do something different. So what's the first step? You've got to write a optimization loop. What do you got to do? 3 things you need to add to the enumeration loop to produce an optimization loop. Yeah?
Optimization variable.
Okay, so we need to have an optimization variable. And if you can't think of anything better to call it, just call it best so far. Now, you want to initialize it. As long as there's at least one number to consider, initialize it to the smallest number. So initialize it to 1. That's the first number in the interval. Then the loop, rather than starting the loop at 1, we'll start the loop at 2. Because we've already got 1 taken care of. Okay? The other thing that's just automatic is when you're done, you return best so far as your answer. What's left to do? We've declared the variable and initialized it to the first element in the collection. After the loop, we return best so far, because at that point it really will be best. What's left to do inside the loop? Yeah?
Test it against the next value.
Right. We need to compare the cosine of best so far to the cosine of our current number. And if our current number, if the cosine is bigger, then it becomes the new champion. So, if the cosine of our current number is greater than the cosine of best so far, we have a new champion. So we need to update best so far. And that's all. Now, the feeling I have is, I give you all this advice. I tell you, okay, you start with the enumeration loop and you add these 3 things. But I get the feeling that when you sit down to do your assignments, this just flies out of your head. And you view each problem as, oh my, how do I do this? How do I write this optimization loop? Well, the thing is, it is virtually identical to the last optimization loop you wrote. They're all pretty much the same. Do you do 3 things? Initialize the create the variable, initialize it to something reasonable. Generally, the first element in the collection you're working with. You return it when you're done, and you have some update thing inside the loop. That's all there is to it. It's just going through the numbers, looking for the one with the highest cosine. Now, what's the difference between this and how do you know this isn't a searching loop? Yeah?
Does it have a return statement in the while?
There's no return statement inside the while. A searching loop will return from inside the while when it finds something it's looking for. This is an optimization loop. A searching loop, you don't have to necessarily look at every element to know you found what you're looking for. Optimization loop has to look at every element to find the best. Okay, here we've got a string. I want to find the largest character in S. the one that comes later, last in lexicographic order. Okay? So this time we're iterating over a string. So I would say, okay, let's go look at an example of an enumeration loop for strings. This is one here. So I'll copy it. I'll paste it here. So this is the bones of our method. Okay? I don't need to print out the character, the s.char out, but I'm going to use s.char out, so I'll just leave this in as a reminder. So that just goes through and touches every character in the string. Okay. We've got to do 3 things to the loop. We need to declare best so far. What will be the type of best so far? Is it a string? Is it a character? Is it an int? Is it a double? How do you know? Now, that's a good clue right there. We're returning a character. We're trying, and it says here, returns the largest character. So yeah, best so far needs to be the type of the thing you're returning. What should we initialize it to? Well, should I initialize it to space? Yeah.
First character on the string.
Okay. What he said. Right. Good thing is to use the first character of the string if the string is guaranteed to be non-empty, and we've got that. It's required to be non-empty. So we just pick the first character from the string and use it. Okay? And the first character would be at index 0. Okay? Now, we don't really need to start the loop at index 0 now because we already dealt with it, so I'll start at index 1. We'll look at the rest of the characters of the string. Okay? The next thing you have to do is really automatic. We just return best so far. And then inside the loop, that's where we do the work. We update best so far if necessary. So how do we know if the current character at the given index is better than best so far? So if the character at the given index is the best so far, we need to update best so far. But how do you know it's the best or better? So there needs to be some sort of comparison in the condition here that tells us that the current character is better than the current champion. How do you tell if one character is larger, comes later in the lexicographic order? Yeah? Yeah, greater than. So if s dot char at index is greater than best so far, we have a new champion, so we update best so far. When the loop ends, the champion will be in that variable we return it. We went through exactly the same exercise as before. We started with the enumeration loop, and we just added the 3 components to make it an optimization. Okay. Any questions I can answer about either of these? This one here, where we deal with intervals, and the other one, where we deal with strings. Yeah?
So, what does the integer index equal 1 do? Like, what does that mean on the find largest chart?
Down here?
Yeah. When it says integer index equals 1, what is that like?
Oh, I'm declaring a variable here, setting its value to 1.
Why?
Okay, who could say why? Why are we setting it to 1? Well, let me ask a different question. What's the purpose of this variable index? What's its role in the loop? Yeah?
Index tracks where you're at in the string.
Right, couldn't say it better myself. Index tracks where you are in the string. So index controls which character in the string we're looking at. So we're going to look at index 1 first. And then each time through the loop, index gets incremented. So the next time through the loop, we'll be looking at index 2, then index 3, then index 4. So we use index to travel through the string.
And then so 1 is just like the position in the string.
Yeah,
Okay.
right. The first character in the string is at index 0, but we don't need to look at it again because we initialize best so far with the first character in the string. And then we look at the rest of the string, and the next character will start at index 1. So we just keep generating new indices. When index becomes too big, that means there aren't any left, so we're done. Loop ends and we return. Yeah?
So what happens if you don't initialize it at all? Like, or not I guess assign a value to it. Like if you just put an index.
If I said index and didn't initialize it,
Yeah.
you're going to get an error message from Java saying the local variable index may not have been initialized. So if Java can't convince itself that you initialized it.
So it doesn't like randomly.
No. She said it doesn't just randomly put something in it. Some languages do that. Some languages you'll just get some random number in there. Java doesn't do that. It makes sure that it's initialized. Okay, any other questions? Okay, how about we got a scanner and we need to find the longest token. So there's going to be a bunch of tokens, think of each one as a word or something. I want the one with the most characters in it. Maybe the scanner's reading from a file, and the file is Pride and Prejudice, and we want to know the longest word that was used in Pride and Prejudice. That might be interesting to find out. You use a loop like that. You just create a scanner to read from the file, and boom. So, where do we start? What's the starting point for any optimization loop? We go to find an enumeration loop. This is the prototypical kind of enumeration loop for scanners. So I'll copy that, come back, paste it. Or if you already have an optimization loop laying around for scanners, you can start with that. So let's see, there's a little bit of mismatch. I called the scanner S there, so instead of scanner, so I'll change that. We're not going to print it out. We're going to do something with S.next. I don't know what. In fact, I'm going to do this. I'm going to say, okay, so each time through the loop, we're going to get the next scanner, the next token out of the scanner. It says here we can assume the scanner is not empty, so that's good. So we need to turn this into an optimization loop that will find the longest token in the scanner. Okay, go. Talk to the people around you. Figure this out.
So we're trying to figure out how to find the longest token?
Essentially check the new scanner after the last one.
Oh, no, I know that S outline is Untitled Chapter.
Declare string, say current longest, and then you scan that if the scanner, current scanner, is greater than that one, go to blanks, then replace current one distinction.
Let's start with longest token.
I'll let you jump.
Oh gosh, why didn't that run? Well, I worked today.
You prefer creative writing than this? But I mean, if I was just writing stories, then yeah, I can see that. But it's always just writing
All right, let's talk about this.
The last assignment, but, you know.
Before we talk about it, Stefan and I were laughing because our big complaint about this room is there's no power to the seats. And it's just interesting to see how you're all adapting. Like today there's power strips back there. I'm envisioning the day where there's like extension cords running everywhere. And then someday the room will catch fire. And they'll wish they'd put power to the seats. Okay, I already have a volunteer to tell me their solution. So what comes first?
We could use the same type of code we use for the find the max of an indefinite number of integers, but we could just use dot length to give us a length and compare those.
Okay, but what do I put before the loop?
You would have to declare the scanner to the first. You already did.
So we got the scanner.
The optimization variable.
Okay, the optimization variable. The optimization variable. Okay, and it should be a type string because that's what each token's a string. And I keep calling it best so far, but really that's not very descriptive. Let's think of a better name. What would be a better name than best so far?
Longest so far.
Longest so far. I like the so far part. But we might as well say what it is. Okay, and we got to initialize it to something. So we just initialize it to the first token from the scanner because we know the token. We know there is one. Okay. What'd you do next? What next? What's the change next?
I would say string token equals
Okay.
math.max.
Well, there's no math.max here. Instead of telling me code, just what's the idea? What's going to have to happen after each time through the loop we're going to read a token?
Yes.
Okay, what do we do with that token? Let me get the answer behind you. Yeah. We're given a scanner. Scanner is a parameter to the method. So it comes in. Yeah.
We have to get the
Right. We have to choose that. I heard the word length anyway. We need to compare the length of this token to what?
S.next.length.
To the length of that. Right? So we need to say if token dot length is greater than longest so far dot length. So this is the part where we need to update the optimization variable. So if the new token is longer, then we say longest so far its token. So that when we're all done, what can we do? Return longest so far. So initialize longest so far to s.next. Update it in the loop, return it when you're done. Yeah?
Won't we either need to move stream token equals x to s.next or put another line somewhere so to make sure that it'll continue going on to s.next and we can keep comparing them instead of the if statement only looping once?
Okay.
Oh, I see. Well, never
Yeah.
mind. I guess, yeah, I forgot there's a while loop.
Yeah, so the while loop is what keeps us going. Now let me tell you, what if I hadn't said string token equals s.next and instead done this? So we say if s.next.length is greater than longest so far, then longest so far equals s.next. What's the problem with that? Yeah. He said longest so far would, well, I'll paraphrase what he said. We're making two calls to s.next, so they're not going to return the same thing, right? This will return the next token, and this will return the one after it. So you have to be very careful when you're using scanners that you only take the thing out once. So I'll put it back to where it was. We need to read it, store it in a variable, and then refer to the variable instead of calling s.next twice. Yeah?
So we wouldn't need to make an index variable for this?
No index variable is necessary for a scanner. There's no indexing operation. A string is random access. You can go to any index and pull the character out. Scanner is not random access. They just come out as you read. But this little loop right here could read, you know, if you open the scanner to take its input from a file, it'll give you the longest word in the file. We'll start looking at stuff like that next week. What about this one?
Yeah.
Returns the integer between 1 and n with the most factors. So 1 has one factor, which is 1. How many factors does 2 have? 2. How many factors does 6 have? Let's see, 1, 2, 3, and 6. 4 factors. So anyway, every number, every integer has some positive number of factors. So we're looking for the one that has the most between 1 and n. And we're going to assume n. Well, if n is not positive, we're going to do something special. Okay? So how would you attack this? What's it going to take to find the int with the most factors? Yeah, in the back? Okay, he said start with an integer-based optimization loop. So let's go, here we have one. So this was the one that we used for integers before, integer intervals. So I will come down here and use it. And we're going to have to do some adjusting because it doesn't involve cosines or anything. Now here it just says if n is not positive, return 0. So to deal with that, what should I do? There's sort of the special condition. It says if n is negative or 0, I've got to return 0. So how can I take care of that so I don't have to worry about it? Yeah? Yeah, we just say if n is less than or equal to 0. Return 0. This is the only time that I write an if without braces. When I can say if n is less than or equal to 0, return 0. So it's sort
Why?
of that's a good question. Why? I don't know. I'm just setting my ways.
Well, why did you do it here then?
That's
why
a good.
is it okay to do it here, not other places?
I don't have a good reason. I'm just telling you. I'm not completely inflexible. Okay. Maybe I shouldn't have done that. It just looks like a lot of stuff just to be returning 0. Stick to my guns. Okay, so if we get past that point, we know n is at least 1. All right, and we're trying to find the best so far. Okay, and really that's going to be, what would be a better name for that? Maybe most factors so far. So we'll just say initially, okay, 1 is the most factors so far. And then we'll start with 2 and try to find a new champion. While num is less than or equal to n, okay, that's right, because we're told how high to go. That's right. This condition here isn't right, but if we find that num has more factors than most factors so far, then we can do the update. So all we have to change here is the what goes in parentheses. The condition. How do we know? How are we going to tell if num, the current value of num, has more factors than our variable most factors so far? That seems hard, yeah?
Is there a math method that will check it?
Is there a math method? If there's a method that will tell me how many factors an integer has, that would be good. But there is not one in the math class, yeah? Yeah?
Well, you'd want to convert n to a double and see if it divides out to an even value or not.
Okay, so he's suggesting about turning into a double, but yeah, you don't want to turn it to a double. You want to leave it integers because there are ways to tell if integers evenly divide. Yeah, double isn't the right idea, yeah?
You can use a mod to see if
Yeah, we can use mod to find out if number is a factor of the other, but we got to somehow count how many factors there are. Yeah?
Do we need to add another loop?
Okay, so, yeah, so given a number and counting how many factors it has is an accumulation loop. And so you might think, oh, I need to put a loop inside the loop to count factors. Okay, let me give you some advice. Don't nest loops until you get really good at writing loops, okay? Having one loop that contains another loop when you barely understand how a loop works is a recipe for disaster. So what should you do instead? We realize that we need, what we're saying is, if only there were a way, if only there were a method to count how many factors a number has, I could do it, right? We would say, okay, if count factors of num is greater than count factors of most so far. Okay, if there were a count factors method, it'd be good, right? That would be our loop. If num has more factors than most factors so far, then we just, we got a new value for most factors so far.
That would just be most factors so far.
No. Most factors so far isn't the count of factors. It's the number that we're worried about. Yeah.
I'm still not clear on what your first if statement that ends with return 0 does.
Okay. So she's asking about this here. So the specification says if n is not positive, you got to return 0. So what this does, if n is not positive, that's what that says. This says in the method, return 0 is the answer. So if n is not positive, this is as far as we'll get inside the method, it'll return.
I was kind of getting that idea, but until a minute ago, I thought that I wasn't sure what the return 0 did, and I thought that the invisible brackets were around
yes,
all the other things in the method.
Yes, they're the invisible brackets. Okay, I'm chastened. I just have to be a purist. Okay, so that ends the method if n is not positive. So this is what I've told you before is the principle of wishful thinking. If you say, I wish I had a method that would count factors, then I would have my problem solved. What does that tell you? It says, I need to implement a method that counts factors, right? It doesn't mean I should nest a loop that counts factors. So you'll have a hard time with that, I guarantee it. It's a lot easier, though, just to go off and write a method called count factors. That'll take an integer and tell you how many factors it has. So if you're wishing for something, that's good. If it already exists, that's better. Unfortunately, Java doesn't have a method called count factors. Fortunately, we wrote one last time, or the time before. Let's go find it. Let's see, product, reverse, indents, all lowercase, sum token. That's not it. Maybe, I don't know. There we go. Returns a number of positive integers that are factors of n. It's not called quite what we wished for, but I think we can deal with that. So it's here, it's in the project, it's in searchingloops.java. It's called number of factors, and it just tells us, you give it 6, it gives you back 4. Yeah?
What day is this from? What date?
Well, this is...
And is it in which class?
I don't know when we did it initially, but it's in today's examples.
Oh.
I copied everything forward. So it's sitting in the same project as the one we're working on right now. So let's just use it. We don't have to do it again. We already did it. How do we make use of it from here?
Call searching loops dot number of factors.
Yeah, so it's called number of factors. So we can do that. We can come to optimization loops. Let's at least call it the right thing. Okay, and I know he knows why it's underlined in red, but someone else tell me. Why is it not happy? Yeah. Right, it comes from a different class. So we have to say, okay, I want search, dot number of factors, and then I'll just copy that. Boom. And there we have it. We're making use of a building block we previously created.
But then seriously, where did you find that? I can't find it.
I can show you after class.
Can you just like say the name of the class?
Searching loops.
I mean,
Searching loops.java in today's examples.
looks like you're looking at enumeration loops.
Okay? What if it hadn't existed? What would you do? Suppose this is your assignment, and oh, rats, it doesn't exist. Do you give up? What does a programmer do when he or she needs a piece, and the piece does not exist? The software part does not exist.
Create it yourself.
Yeah?
Make it.
You make it. That's what programmers do. They make parts. In this case, we were lucky. The part we needed was exactly as we needed, except maybe it's called something different. But that's what programmers do. Okay? So far, you haven't had to do that. You haven't had to create helper methods to get the method that you're working on to work. But it's not an uncommon thing. And believe me, if this had not existed, if number of factors had not existed, it would be a lot easier to go off, stop what you're doing, write number of factors, and make sure it works correctly, and then come back and make this work correctly. That's a lot better idea than trying to nest loops one inside the other. Anyone know why? Besides the obvious complication? Why is it better to have two methods, two simple methods, than one complicated method? Back there. Yeah, you. You. Okay, one thing is you have the method now to use in the future. Yes?
It's easier to read.
It's easier to read. Yeah? Easier to debug, easier to test. Right? It's easier to test two simple things. So what you would do is you would test the factor counting method until you're really sure it works. Then you can use it in this method here. You won't have to worry, oh, is the number of factors the problem? Or is the other code the problem? And you can concentrate on the other code if something doesn't work. So there's a big advantage to breaking things down into smaller pieces, to individually testable. That's just what programmers do. Okay, what about this one here? Find token with largest character. So we're going through a scanner, we're looking at each token. Now, I want to find the token that contains the largest character. Okay? So I don't have time to do it, but we got time to talk about it. How would you approach this? I mean, clearly you'd write an optimization loop. But how would you got two tokens. You got to figure out which one contains the largest character. How would you do that? Yeah?
We've already done it.
Right? We have a method up here. Right there. Find largest character. We have a method that when given a string, i.e. a token, will return the largest character from it. So down here, if we were to write an optimization loop, that the if that goes right here, would be using that method to pull out the largest character in one token, pull out the largest character in the other token, and then we could compare them with greater than. So again, we lucked out and the method that we needed already existed. Okay? And I've said before, you take a 1,000,000-line program, a 10-million-line program, those are massive, no way around it, but they consist of lots of small parts. That's the only way people can think about it. People can't think about 1,000,000 lines of code. People can think about, collections of small parts. That's the name of the game. So that's what we hope we get better at. Okay. So that finishes up what we're going to say about loops. Next week we're going to get into some topics that will let us write realistic programs, not just pieces.